Hi everyone, this is Dr. J. Ravindranath Reddy working as Assistant Professor in MLR Institute of Technology, Hyderabad. So here we are going to discuss how to find out the Fourier series of an even function in the interval minus L comma L. In the previous video, we have seen how to find out the Fourier series expansion for an neither even nor odd function in the interval minus L comma L. So here now we are going to see how to find out the Fourier series for even function in the interval minus L comma L. So now we will see, already we have seen in the previous videos how to define the function as even function or odd function here, and similarly have taken a function f of x, and in that f of x replace x with minus x here. So if you get that f of minus x is equal to an f of x, once again this function we can call it as an even function. So for this even function we are going to find out the Fourier series in the interval minus L comma L. Okay, now so whenever we are having an even function in the interval minus L comma L, we will get a Fourier cosine series here. So why cosine series means, so in this the second, while you are finding that Bn value, so you will get that Bn is equal to 0 in the interval minus L comma L whenever the function is even function. So since Bn is equal to 0, then we can neglect that third term which contains Bn sin n pi x by L. So that value becomes 0. So after neglecting that third term, we will get f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity a n cos n pi x by L. So here once if we observe this Fourier series, in this we can find only cosine terms. So since only the cosine terms are present in the series, so we can call it as a Fourier cosine series. So in this we have to find out two coefficients, that is a0 and an. So that a0 value is given by 2 by L integral 0 to L f of x into dx, and an is given by 2 by L integral 0 to L f of x into cos n pi x by L into dx. Now let us take one example how to find out the Fourier series of f of x for even function in the interval minus L comma L. Now this is the function he has given, f of x is equal to x square, and now for this f of x is equal to x square, we have to find out the Fourier series in the interval minus L comma L. Here he has given the same interval, the standard interval minus L comma L. Now let us take this function, and so whenever we are going to find out the Fourier series for the given function in the interval minus L comma L, first we have to check whether the given function is an even function or odd function or neither even nor odd. So first we have to concentrate on this. Now let us take the function and we will check whether the given function is even function or not. So now this is the function. Now we know the definition of even function, replace x with minus x here. So f of minus x is equal to minus x whole square. Once again you will get that value is equal to x square, that is given by f of x. So f of minus x is equal to f of x. Then this is the condition of an even function. So we can decide the given function is an even function in the interval minus L comma L. Now let us take the standard formula to find out the Fourier series for a even function in the interval minus L comma L. So just now we have seen the standard formula to find out the Fourier series, that is given by f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L. This is the standard formula to find out the Fourier series of an even function in the interval minus L comma L. And a0 value he has given as a0 is equal to 2 by L integral 0 to L f of x into dx, and an to equal to 2 by L integral 0 to L f of x cos n pi x by L into dx. Now here no need to substitute any value for L. So we are having the same interval minus L comma L. So wherever we are having L, you keep that L as it is here. Now let us take that a0 value and our function here, this is the standard formula. So by using this standard formula, we are going to find out this a naught value, that is 2 by L integral 0 to L. So f of x, replace that f of x with x square here. So integral 0 to L x square dx. We know that integral of x square is x cube by 3, and substitute the limits here 0 to L. So you will get this value is equal to 2 by 3L. Take this 3 outside since it is a constant. So you will get L cube minus 0 cube, that is 0. So 1L gets cancelled here. So totally you will get 2L squared by 3. So this is our value of A naught. Okay, so we got A naught is equal to 2L squared by 3, and similarly we can find out the value of Bn. So Bn value has An value. An is equal to 2 by L integral 0 to L f of x cos n pi x. Replace that f of x with x square value here, and now here inside the integral we are having the product of two functions, that is x square is one function and cos n pi x is a trigonometric function. Now to evaluate this integral, we have to apply integration by parts. We have the formula, that is integral of u into v dx. So this is very important formula. So this can be written as u into v1. v1 is integral of v minus u dash, that is derivative of u into v2. v2 is integral of v1 plus, and so on. We have to go for until we get the derivative of u as a constant value. So u double dash into v3 plus minus, and so on. So now u is a algebraic function, that is x square, and cos we have to consider this one as v. So integral you keep as it is, substitute the value of u here x square into v1, that is integral of cos. Integral of cos can be taken as sin n pi x by L, and once again you take the derivative of this and write down the derivative with respect to x in the denominator. So you will get n pi by L minus u dash. Our u is x square, derivative of x square is 2x, and this is our v1 value. Now for this function you find out the integral once again. So integral of cos we can take it as minus cos n pi x by L. Already in the denominator we are having n pi by L. So once again if you find out the derivative of this, once again you will get another n pi by L. So totally we are having n square pi square by L square plus. So alternatively you have to keep plus and minus here. So plus 2 times derivative of u, that is first time derivative is 2x. So once again if you apply the derivative of this 2x, you will get that value is equal to 2. So since the derivative of u is constant, no need to go for the next term. So you can stop over this uv formula up to this point. So 2 into, so this is our v2. Once again you find out the integral of v2, so minus integral of cos we can take it as sin n pi x by L by, here we are having n square pi square by L square as the denominator. Once again if you find out the integral this for this derivative of this, we can get another n pi by L. So totally you will have n pi by L whole cube, that can be written as n cube pi cube by L cube. So now after applying this integration, now we have to substitute the upper limit and lower limit here. So when we substitute the upper limit and lower limit here, so finally when we substitute this upper limit and lower limit here, so this first term and this last term becomes 0, because if you substitute x is equal to L here, upper limit here, so here you will get L. So this L and this L gets cancelled, you will get sin n pi. So we know that sin n pi is equal to 0. So we can neglect this, and similarly when we substitute the lower limit in this first term, you will get sin 0. Sin 0 is also 0, so we can neglect. For both, while you are substituting the upper and lower limit here in the first term, both values become 0. So we can neglect this. And similarly take this third term here. If you substitute x is equal to upper limit here, you will get sin n pi. Sin n pi is also 0, 0 by anything equal to 0. And similarly, if you substitute the lower limit x is equal to 0, so here 0 n pi into 0, that is 0, sine 0 is 0. So even though if you substitute this lower limit in the third term, that value is also equal to 0. So this first term and this third term, in both terms, if you substitute both even this upper limit and lower limit, these two values are equal to 0. So we can neglect these two terms here. Now the remaining term is this one. So finally we got this term, that is minus into minus plus 2 by L, 2x into cos n pi by n pi x by L by n square pi square by L square. Now you substitute the upper limit and lower limit here. So if you substitute here, so you will get this value is equal to 2 by L into 2L. Because we are replacing the upper limit in place of x, replace upper limit L. So 2 into x, that is 2L, cos n pi x, x is L by L by this denominator L n square pi square by L square minus, substitute x is equal to 0. So if you substitute x is equal to 0, 2 into 0, 0, 0 into anything equal to 0, 0 by anything equal to 0. So that entire term becomes 0 after substituting the lower limit x is equal to 0. So this L and this L gets cancelled. So finally you will get 2L cos n pi by denominator n square pi square by L square. Okay, so this is the value of EAN. Now we got A0 value, EAN value. Now you substitute these two values A0 and EAN in equation 1, we can get our required value here. So A0 2 L squared by 3 by 2, 2 gets cancelled. This finally you will get this value is equal to L squared by 3 plus summation n is equal to 1 to infinity, and this is the value of AN into cos n pi x by L. Now take this 4 is constant, L square is constant and pi square is constant. So you take these terms outside this summation, and finally you will get minus 1. So if you take this plus as minus of minus, you send this 1 minus inside, you will get minus 1 whole to the power of n plus 1 by n square cos n pi x. Now 1 by 1 substitute the values of L is n equal to 1 to infinity, you will get our required Fourier. Suppose if you take n is equal to 1 here, minus 1 whole to the power of 1 plus 1, that is 2 whole minus 1 whole square, that is plus 1. So by 1 square n pi x, n is 1, so pi x by L, minus you take n is equal to 2 here, so you will get a negative sign, and like this by substituting n is equal to 1, 2, 3, 4 and so on, you will get the total number of n terms in the series. So once if you observe this entire series here, except cos function we don't have the sign, except cos function we don't have another sign. So entire this Fourier series is in terms of cos. So this we can call it as a Fourier cosine series. So whenever we are having a even function in the interval minus L comma L, you will get only Fourier cosine series here. So we don't get any cos, we don't get any sine series here. We will get only in terms of cos. So now in this video we have discussed how to find out the Fourier series of an even function in the interval minus L comma L. Now in the next video we will take an odd function in the interval minus L comma L, and we will see how to find out the Fourier series expansion. Thank you all of you.